These can be a little tricky. First of all, we're not going to use our methods for solving limits on this. Okay? In other words, you're not going to treat this as a limit problem. You're going to treat it as a derivative problem. Okay?
How do I recognize I have to treat it like that?
What's that?
How do I recognize I have to treat it like that?
Mainly because of this word right here, differentiation. In other words, it's not a limit problem. What it is knowing what the definition of differentiation is. Well, remember what the definition of differentiation is. It's the limit as h goes to 0 of f of x plus h minus f of x all over h. So this is really what we want to think about, is this definition over here. Well, when we look at that, what is f of x? It's the cube root of x. In other words, if I said f of x equals the cube root of x, which is x to the 1/3, well, what would f prime be? In other words, don't solve it as a limit problem. Recognize that the limit they're talking about is the function x to the 1/3.
It would be
evaluated at 8. So when you take the derivative, what do you get?
You get
Always start with the exponent.
yeah. Then to the x to negative 2/3.
Okay, now the key is you're going to evaluate that at 8. In other words, that's what you have right there, is 1 over 3x to the 2/3. That's the derivative function. And we're evaluating it at 8 because of that 8 right there. That's how you get 1/12. Now, this would actually be a limit problem that would be fairly difficult, because remember that usually when we see radical signs and limit problems, we want to multiply by the conjugate, but not when you have cube root. I'm not real sure how we would solve that as a limit problem. So that's the whole reason they give it to you, is because it's very difficult to solve using your rules for limits. However, if you recognize that it's f of x plus h minus f of x, and we're going to evaluate it when, in other words, as long as we can figure out that that's x to the 1/3, notice that if they gave us the function, let's say they told us f of x is x to the 1/3, okay? Well, then what do we have? We have f of x plus h to the 1/3 minus x to the 1/3 all over h, and x must be 8. If we substitute 8 for x, we get this thing over here that we're looking at. That's what this would be the cube root of 8 plus h. This would be 2, and there's the h. So we can figure out what f of x must have been had to be x to the 1/3. Now, it's not that obvious how to figure it out. Let's do another one, just so we can see a little bit more how this works. So this is a similar problem. It's going to be tough to solve this using our rules of limits. So what do you think the function is?
2 plus h to the 5th power.
Just x to the 5th power. Now,
how is it just an x to the 5th power?
Well, first of all, because x is going to be 2, right? In other words, see that 2 and see that 32? Well, 32 is 2 to the 5th. I'm trying to explain this a little better. This is a difficult problem to explain. I understand it myself, but just barely. Let's start from if they would have given us that. Okay. Now, what do we know about f prime? The first derivative is equal to the limit of f of x plus h minus f of x all over h as h goes to 0. Well, let's plug in. That means f prime of x equals to the limit of, well, in this case, it's x plus h to the 5th power minus f of x is x to the 5th power all over h. So that's what we know f prime of x is. Well, if we look and we see a 32, that means 32 is x to the 5th. So x is 2. And that also means that is correct. In other words, x plus h is 2 plus h to the 5th. So what I know here is that my original function is x to the 5th. This is the first thing you got to really figure out on these kind of problems. Now, their questions has to do with the derivatives, all 5 answers. So let's figure out what is correct. What is f? If f of x is x to the 5th, what is f prime of x?
It would be 5.
5x to the 4th. That's a true statement, correct?
Mm-hmm. Wait, so would you plug in 2 or would you plug in 5?
Well, we have to first of all analyze everything. Okay? In other words, we're trying to pick one of these choices that's correct. Well, that clearly is not correct because f of x is not 2 to the x. F of x is x to the 5th. Well, the only thing I see down here is that, where f of x is x to the 5th. Now the question is, f prime of 2 is what they're talking about here. In other words, they made x equal 2. So what this thing is that we're looking at is f prime of 2, where f of x is x to the 5th. It's exactly what it is. I realize that I'm not helping a whole lot. I think the way to really get this down is to just do more of them, but I think we ran out of these kind of problems.
Mm-hmm.
The key is this right here. Now, let me change color. The key is knowing that right there. what is the limit definition for first derivative? Once you know that it has to be this, then when you look at what they're giving us, f of x has to be x to the fifth, and x has to be 2. So this must be the derivative function evaluated at 2. In other words, over here where it says, what is f prime of 2? Well, that's what that is. Only that's not enough to say. You have to also tell it what f of x had to be. Well, could have been 2 to the x, but that doesn't equal that. In other words, if the original function was 2 to the x, you wouldn't get this. You wouldn't get 2 plus h to the fifth. You would get 2 to the x plus h. Right? Here,
Yeah.
I want to make sure you understand this because this isn't all that clear. That can't be the original function. Because if it was, then the first derivative of x would be the limit of 2 to the x plus h minus 2 to the x all divided by h. So that's what we'd be looking at. And that's not what we're looking at. That's not what that is. That's clearly not 2 to an exponential power. It's x to the fifth is what it is. If my original function were x to the fifth, then f prime of x would be the limit of x plus h to the fifth minus x to the fifth all over h. And if I'm evaluating it at 2, then I can substitute 2. So f prime of 2 is now going to be the limit of 2 plus h to the fifth minus 2 to the fifth all over h. That's exactly what we're looking at. So it kind of requires you to be able to work forwards and backwards, which is hard, given that this is fairly hard to work forwards. But they haven't really asked us to work forwards on any of it. In other words, the way I would solve this problem is I would go ahead and expand 2 plus h to the fifth power and then simplify. But they don't want us to do that, and that's why they made it such a large exponent. They want you to understand what you're looking at. You're looking at an original function that is x to the fifth, and you're evaluating the derivative at 2. That's why D is the correct answer. What we're looking at is the derivative evaluated at 2 with this as x to the fifth as our original f of x.
Okay.
All right, let's go on. There's such a thing as beating a horse to death. Those are both fairly tough problems, but doable if you really understand what that definition limit means.
Mm-hmm.
All right, so let f be the function given above, which is piecewise. Which of the following statements are true? The limit of f of x exists as x approaches 1. How are we going to determine whether that's true or not?
If they connect, and if
It's not so much if they connect. It exists if the limit as we approach 1 from the left equals the limit as we approach 1 from the right. So what is the limit as we approach 1 from the left, which would be using that function. Hold on. In other words, we're going to use that function right there as we approach 1 from the left. Well, what's that limit?
It would be 1. Negative 1.
Negative 1. Now, when we approach it from the right, we're going to use this function.
And that would be negative 1.
Also. So the limit from the left is the same as the limit from the right. Therefore, we can at least say that that's true. The limit exists. Now, is f continuous at x? Well, there's a third statement that has to be true for something to be continuous. And that is the limit from the left has to equal the limit from the right, which both have to equal what the function is at 1. Well, what is the function at 1?
They both have to be greater than or less than and equal to in order for it to work.
You only need one further thing to make number 2 true. We already know that the limit exists. That's 2 of them. That means that the limit from the left is equal to the limit from the right. They're both negative 1. Okay? Now, the only other thing that has to be true is that f of 1 also has to equal negative 1. If it does, then it's continuous. So all you have to know is 3 things. Limit from the left equals limit from the right equals the value at that number. Well, what is f of 1 in this case? Which function do we use? Top or bottom?
Top.
And what is f of 1?
Negative 1.
Therefore, that's true. That is the mathematical definition of continuity. In other words, most people think of continuity as if I don't have to lift my pencil, it's continuous. And that's a true statement, but there's a mathematical definition also, which requires 3 things to be true. Limits from the left have to equal limit from the right, has to equal the value at that number. Now, number 3, f is differentiable at x1.
No, because it's like a corner, so that wouldn't work.
It could be a corner. In other words, if I had a corner, let's say I had a function like this, well, the limit is certainly going to be the same from both directions.
But then you also have the one that's flat. So
it's also going to be continuous because it's equal to that at that number, but it's not differentiable because the slope from the left is not the same as the slope from the right. Notice the slope from the left is minus 2, first derivative of that top function. And the slope from the right is minus 2x. Well, those aren't the same. So, so it's either C or E. Now, how do we know it's not differentiable at x?
Yeah.
That's the
because
question.
3 different possibilities.
A corner or a cusp. I guess we know by merely what that function looks like.
Doesn't that not matter anyway? Because they all exist and they don't exist.
To graph that thing, there's 1. We know it's linear heading into that. And we know that it's parabolic coming out of that. Well, that's a corner. You can't smoothly connect a straight line with a parabola such that it's differentiable there. That is a corner or a cusp. And I think actually the proof of that was analyzing the slope to the left and to the right. If they're not the same, it's a corner or a cusp.
Mm-hmm.
All right, let's go on to 4. Oops, hold on. I presume you want to just do all of these, right? I mean,
Yeah,
I see a lot of writing, so I don't want to go over one that you know how to do. Tell me what our strategy for number 4 is going to be.
so you just want to take the derivative, and when you're taking the first derivative, you're gonna use the product rule.
Okay, let's do it.
So first off, you're gonna have x.
In other words, we're going to figure out what f prime of x is.
Yeah, so
We're not going to use, there's 2 different formulas. We could figure out what f prime of 1 is only, but I really don't like that method. I want to figure out f prime of x, and then whatever we get, we'll substitute 1 in and see what number we come up with. So using the product rule.
So you're going to start off with x cubed minus 2x plus 5.
Parentheses, okay.
And then you're going to multiply that by negative 2x to the negative third power minus 1x to the negative 2 power.
It's funny, this pink works on some backgrounds and it doesn't work on others.
It works for me, don't worry.
Yeah, this is definitely a background where I should not have used it. Okay, what's the rest of it?
And then you want to multiply it, add 2x squared, no, 3x squared minus 2 multiplied by x to the negative 2 power plus x to the negative 1 power.
All right. So
and then
that is our derivative function.
Yeah, and then you just plug in 1, and then you should
get plug in 1, what do we get? We get 1 minus 2 plus 5.
Oh, and I had a question. So when you have like to the negative power, what do you do? Like, because I know how to plug it into a calculator, but I don't know how to actually do it.
I'll show you. As all I'm doing is plugging in 1 wherever I see x.
Yeah.
Okay, so the next part is minus 2 times 1 to the negative 3 minus 1 to the negative 2 plus 3 times 1 squared minus 2 all times 1 to the negative 2 plus 1 to the negative 1. Okay? Now let's simplify all of these. Well, 1 minus 2 plus 5 looks like 4. 1 to the minus 3 means 1 over 1 cubed. That's what it means.
Oh, okay.
Okay.
With the 2 dragged along with that, would it just be
minus 2 minus, this is just 1. In other words, 1 to the minus 2 means 1 over 1 squared.
Would the 2 be like dragged along with that, or is it just the 1 that's 1 over 1 cubed?
A negative exponent always means 1 over that number to the positive exponent.
But like you're not concerned about the coefficient at all.
Yeah. In other words, I'm just simplifying this at the moment. So all I'm doing is I'm figuring out what minus 2 times 1 to the negative 3 is. Well, that's minus 2. Okay, 1 squared, or 1 to the minus 2, that's 1. So that's minus 1. Plus, this is 3 minus 2, so that's 1, times 1 plus 1, times 2. So what we now have is minus 3 plus 2, that's minus 1, times 4. No. Well, I've made a mistake in my arithmetic here. And
it should still work if you just put parentheses around it.
What's that?
It should still work if you just put just another parentheses over -2 minus 1.
Well, that's minus 3.
Yeah.
Plus 2 is -1. All times 4, I'm getting -4 as an answer. And do we know what the answer is?
I think you're doing your arithmetic wrong.
I'm sure I am, but unfortunately, that's the problem when there's lots of arithmetic and you get an answer that's not on your multiple choice. You know you made a mistake, but figuring out where is the question.
It's right here. It's just because you subtract 1 from 2, so you get -3. Then you multiply -3 by 4. And then you get -12, and then you add that by 2. Yeah.
And that's why minus 10 is the right answer.
Yeah.
Okay. I see. Yeah, you actually did this correctly, exactly correctly. Yeah, you're right. I did just have my parentheses in the wrong place.
Yeah.
Okay, cool. But that's what you do. You find the derivative, and then you substitute whatever number is in the parentheses into your derivative function.
Okay.
Okay. Let's see. There were a couple of pages here, weren't there?
Yeah.
Yeah, let me go up and find the next one. This must be, oh yeah, got all kinds of them here. Which one do we want to look at first? Do you know the order of these by chance?
I was just wondering if you could go over number 5 if you could find it. I think it's...
Do these black stars mean anything?
No.
Okay, I can open it real quick. That's what we just left.
That's the first page, so it's probably
the first one. So it must be this one here.
Yeah, it's that one.
Okay, cool. Let me download that, and then I'll be able to move it around. Okay. If y equals x squared times some function of x, then y double prime equals what? Am I reading it properly?
Yeah, so I don't know what to do there.
Okay. Well, let's use the product rule and figure out the first derivative. Then whatever we get, we're going to figure out the second derivative.
Okay, so...
Okay. So tell me what here, and this time let me change colors. Tell me what y prime is.
Would it be x squared times f prime of x?
You got it.
Plus 2x times f of x.
Now figure out f double prime. Notice that all these answers are in terms of f prime of x and f of x. So we don't need to know what f of x is. Just need to apply the rules of differentiation.
Okay.
Okay. Do it again. We got two products here.
So would it be x squared times f double prime of x, and then 2x times 2x. No, wait, yeah, plus 2x f prime of x.
Now, all of that I just wrote is just that.
Yeah.
Now let's do the other half of it.
And then so you do plus 2 x.
Always start with the u, okay?
Yeah. And then times f prime of x plus f, no, it'd be, yeah, it would be 2 times f of x.
Now, let's see if that's on there. First of all, do we have anything that we can combine? Yeah, I got a 2x f prime of x and another 2x f prime of x.
So that'd just be 4x f prime of x.
F prime of x. So it's one of these two answers here. And what else do we have? The first term is correct. The second term is the same. The only thing left is that. So the answer is D.
Okay.
Okay. And notice that we never figured out what f of x is. We didn't care. We just applied the product rule. All right, let's look at 6. I presume, unless you have something else, since we might have time to go over. Well, we're not going to cover all 5 of these pages for sure.
Oh yeah, I was probably just imagining we'd get through like a little under half because it's a lot of.
Yeah, we got another session tomorrow, so we'll finish the rest of it.
That definitely works out. So,
what's the best way to write f of x for number 6?
I just wrote that down, but I literally have no idea how to do this problem.
Radical signs do not work in calculus. So convert it to exponentials.
Okay, so
What I write
so it'd be x plus root x to the 1/2. No, plus x to the 1/2, all to the 1/2.
There you go. Now we can differentiate it, right?
Okay.
Now we don't have any radical signs left. You are going to have to use the chain rule. Because what is our inside?
Oh yeah, so
What's the inside? Tell me.
the inside is x plus x to the 1/2.
Okay. Now take the derivative of the outside.
So it would be 1/2 times x plus 1/2 x.
Hold on. Don't change the inside. That's the derivative of the outside.
Yeah.
Okay.
And then
now you got to multiply that by the derivative of the inside, which is what?
1 plus x. No, wait, 1/2 x.
Exponent
So it'd be 1/2 x.
to the what? Now subtract 1 from the exponent.
Negative 1/2.
All right. So this thing at the bottom times the thing at the top. Now, the tough part about this is they got all their answers with radical signs. So let's see if we can figure this out. First of all, I'm going to take this. I'm going to make it in the denominator. See why? Because it's got a negative exponent.
Yeah.
So I'm going to take what it was being multiplied by. Let's start with this. This is what I was multiplying it by. which means if I put all of this in the denominator, you with me? It's a little confusing. That answer on the right is the same as what I've written on the left. In other words, I've taken what it was multiplied by, made that in the numerator, and I've taken everything else and put it in the denominator. Only this 1/2 doesn't go there. That should be a 2. In other words, the 1/2 was not being taken to the negative 1/2. So that is just a 2. Okay, now let's see what happens when I put radical signs back in. Let me think for a second here. All right, I can erase what I got on the right. In other words, is all I have to do is simplify what I have on the left, and I'll have my answer. Not that it's any piece of cake to do, but I think we can figure it out. All right, let's talk about this numerator. That is 1 plus 1 over 2x to the 1/2.
Yeah.
That's what that numerator is.
How do we deal with that 1 over 2?
Well, we're going to use a common denominator. Okay, in other words, we're going to add these two things together. So the new common denominator is 2, and this is just for the numerator. Well, for that to be 1, it's got to be 2x to the 1/2 plus 1. You see where that's true?
Mm-hmm.
Now notice that everything is in terms of positive exponents. So this is my numerator. This is my denominator. And which means that this 2x to the 1/2 can go in my denominator. So now my numerator should be 2 times the square root of x plus 1 all over. This is 2 times the square root of x, and I have another 2 times x plus square root of x square root of. So there's what we're looking for. Notice my, no, can't do that. So my numerator looks like that, right?
Mm-hmm.
My denominator looks like this. Doesn't quite look like that, but I can certainly see where they get the 4. And if I distribute this, what do I get? I get 4x to the 3/2 plus x. There's the x to the 3/2 right there. X times square root of x.
So would you say?
In other words, I didn't need to multiply those together.
Mm-hmm.
Yeah, in other words, that denominator that we're looking at in answer D is what I have, I believe. In other words, it's 4 times the square root of x squared plus x times the square root of x. Well, the algebra is just brutal here. There's your x times square root of x, what I just underlined. And that times that is the square root of x squared. That's what that is. Now, how I get from one to the other, boy, I've seen some hard algebra in my life. This might be the hardest that I've ever seen.
Yeah, it's pretty complicated.
D is the answer for sure.
I can check in the back.
Well, because I'm thinking E looks more right. In other words, look at my denominator. If I distribute this, I get 4 square root of x times square root of x is just x, plus the square root of x times x is this part here. I don't know. I'm confusing myself. I got so much written on here that I've lost track of where I'm at. Somehow we have to get from what I have circled over here. That was my original denominator. Once I found a common denominator in the numerator, then that became my numerator, which put the 2x to the 1/2 in the denominator. So I got a 4x to the 1/2 right there. That should be my denominator, what I've circled. 4, here, let me rewrite it. This should be my denominator. 4x to the 1/2 times x plus x to the 1/2 all to the 1/2. Well, what is that? That is 4, I'm running out of room here. That is 4 square root of x times the square root of x plus the square root of x. Which answer is that?
Damn, this is confusing.
Oh, it sure is. These are both to the 1/2, so I can combine them, and I can take this and I can put it inside this radical sign. So that becomes x squared plus x times square root of x. The answer is definitely D. In other words, I was able to eventually solve it. Once I realized that it was 4 square root of x times the square root of all this other stuff. Well, if you have the square root of something times the square root of the other, you can multiply the insides and take the square root of all of it. And that's what the denominator does on 4, is multiplies the insides to end up with the square root of x squared plus x times the square root of x. Yeah, this problem is a, I don't know what to call it. a test of patience, but it's mainly an algebra problem. It's a very complicated algebra problem. And the key to this problem is what to do with the numerator. This numerator right here, that numerator, you have to combine that into a single rational quotient, which I did. Now you can deal with the whole thing. In other words, this is our new numerator, which means this denominator goes in the denominator. My denominator is still there, but this joins it. And so I have this in the top and whatever you get in the bottom, which simplifies to what they've got in the denominator for D. All right, again, we've probably spent too much time on that, merely because it shouldn't be a test of algebra. It should be a test of calculus.
Mm-hmm.
And I kind of feel like we're doing more algebra than calculus. I understand why they want to, but all right, this one's fairly straightforward.
So would it be the chain rule here? The double chain rule?
Yeah, exactly. So tell me what f prime of x is.
So it would be cosine of cosine 2x times sine, negative sine 2x times 2.
Yep.
So
I'll put the 2 there.
So then this would...
Let me rewrite it again. In
Okay.
fact, I'll go ahead and I don't need to rewrite it. I'll just plug everything in. Okay?
I don't know how trig functions really work, to be honest.
Okay, well, first of all, let's plug it in. 2 cosine. Well, the cosine of 2 of those is pi over 2, right? Here, let me back up. Let me do exactly as I said I was going to do, which is merely plug it in and then simplify. So we're taking the cosine of 2 times pi over 4 times minus sine of 2 times pi over 4. And let's take that minus and stick it there so it doesn't get confused with subtraction. Now we can evaluate it. First of all, the cosine of pi over 2. I'm going to draw the sine curve, and then I'm going to draw the cosine curve. There's pi over 2. It's the cosine of pi over 2.
1.
Read the graph. What's the y coordinate where it crosses the x-axis? And cosine is 0.
Oh, 0. Okay.
Okay. Well, that means that's 0. So what's the answer?
Oh, it's just 0 because it makes everything else.
We've got the product of 3 things, one of which is 0. Hold on a second. No, that's not correct. This is a little tricky. We don't have the product of 3 things. We've got the cosine of 0. Well, what's the cosine of 0 if you read the pink from the graph?
Cosine of 0 would be 1.
Right. Okay. In other words, we're not multiplying 3 things here. We're taking the cosine of 0. So that whole thing is 1. Now, the sine of pi over 2 is also 1. So our answer is 1 times minus 2. Right there.
Okay.
That is very tricky because it's very easy to leap to the wrong thing once you see a 0. Because your eyes look like we're multiplying 3 things together, and we're not doing that.
Yeah, because it's inside the
trig function of 0, which is not 0, it's 1. So, okay. So we got about 5 minutes. Let's try to get into.
It's pretty straightforward, so I was just wondering if we could go to the next page.
Okay, sure. Let's see what happens if I do that. No, that doesn't work. Why is this not? I Let's see what I got to do. Okay. And this is the next page, the middle one, right?
Mm-hmm.
Looking for number 9, I presume?
Yeah, that would be it.
Unfortunately, the top left is cut off.
Oh, I got it. It's okay. It's even cut off for me actually. So it's d over dx equals secant. Yeah, it's just the only part that you're missing is.
Just take the derivative of secant squared of square root of x.
Yeah.
Okay.
So I noticed that this was also a chain rule.
Hold on. Let me get started here. Let me write it this way. Y equals secant squared of square root of x, which I'm going to write as x to the 1/2. I'll skip a step. Okay? So now y prime. The derivative of the outside.
So just make it 2 secant x to the 1/2.
What's the derivative of the first inside? Because we got 2 insides here. What is the first inside?
The derivative of the first inside would be 1/2 x to the negative 1/2.
That's the second inside.
Oh, I'm confused.
Well, here, let me straighten you out.
Oh, okay. Actually, I understand. So I don't know what this
derivative of this is.
I have no idea.
You apply the power rule, and then the inside is secant of x.
Yeah, I don't know it. I don't know what the.
Okay, so this would be 2 secant of x. That's the derivative of the outside using the power rule.
Yeah, but I just don't know how to take the derivative of secant. I forgot it.
Secant tangent.
Okay.
So that is the derivative of the first inside. Okay, so I want to, the first inside is secant of x to the 1/2 tangent of x to the 1/2. So there's the first inside. The first inside is secant of x to the 1/2. That's the first inside. And that's the derivative of that. It's the secant of x to the 1/2 times tangent of x to the 1/2, but we still have to multiply everything by the derivative of the second inside. So I've run out of room here, so I'm going to do it like this. What's the derivative of the second inside?
The second inside.
Mm-hmm. What is the second inside?
Negative 1/2. No, 1/2 x times negative to the negative 1/2.
There's the second inside. So I'm multiplying. Here I have the secant of x to the 1/2 times that times this. So I am multiplying 3 things together here. But this is tricky because of that. Here, I think I can straighten it out a little bit for you. Let's see, do we have the answer here? Yeah. The answer is C. Notice the 2's cancel. So the bottom is just going to have square root of x. Whoops, excuse me. And the top is, we got secant times secant.
So that's square root of x.
Secant of square root of x times tangent. Yeah, I can certainly multiply that by that.
Yeah.
And that gives me secant squared of square root of x. And then I multiply that times this. Oh, no, I don't need to multiply anything more.
Yeah, because those are just like terms.
Yeah, no, I don't want to multiply it twice. I'm multiplying three things together. I just needed to multiply that times that in order to get this secant squared.
Mm-hmm.
And the 2's cancel, so I end up with C. Again, not complicated trig, complicated algebra. This is strictly an algebra problem. You don't have to know anything about trig. All you need to know is that secant of x to the 1/2 times secant of x to the 1/2 is secant squared of x to the 1/2.
Mm-hmm.
All right. 9 is probably about halfway through. Good stopping spot?
Yeah, I'd say so.
Wow. These are outrageous.
Yeah, he tries to format them in the way that the AP test is, so it's like...
I was just going to say, no. You will not find problems like this on the AP exam.
You won't?
Nope.
Huh.
You'll find tough problems, but not this level of algebra tough.
So it's more like...
I might be wrong. But you know what? I've tutored the AP test for quite a few students, and I have a number of practice exams that I've been through. So I am familiar with what's on the AP test. The degree of difficulty from the AP test doesn't come from hard algebra like these.
It comes from hard calculus.
No, it comes from the concepts. Yes, hard calculus, exactly. This is not hard calculus. This is easy calculus. It's just hard algebra.
Yeah.
Well, yeah, at some point we'll work on the AP exam, I presume.
Yeah, we probably
won't be until May or April when you start preparing for it. But yeah, I've got some practice AP exams, and I can certainly show you the kind of stuff that's on the AP exam. It really isn't stuff like this.
Okay.
I hate to make a blanket statement like that, but I do remember it, and it's not super.
I'll trust your judgment on it. It makes sense to me.
Yeah. Yeah. I don't know why he's kind of doing this to you. It's not to prepare you for the AP exam. There's a lot of better problems to be looking at to prepare you for the AP exam. There's a lot of word problems on the AP exam. There's optimization problems. There's related rate problems. You haven't gotten to either optimization or related rates yet, have you?
No, we've gotten to related rates.
Okay. That's right. We've done some related rates. But yeah, that's really, he's spending way too much time on this stuff here.
Yeah.
Merely a test of algebra, and it's hard. It's hard for me to do. I feel like I'm pretty good at algebra. So anyway, I will talk to you tomorrow night at 7. Jake?
All right, sounds good. I'll see you later.
Okay, bye-bye.
Bye.